Here's the third problem from the task today. So the first thing we're going to do here is we're going to identify our main feature points like we have in every other problem. And the first thing we're going to do is set the numerator equal to 0. If I set the numerator equal to 0, I'm going to solve and I get an x value of 0, which means I have a coordinate point at 0, 0, which is the origin. The y-intercept, same thing. If I plug 0 in for the x and a 0 in for the, both x's, top and bottom, you're going to get 0 over -3, which is a y value of 0. So again, that gives you a coordinate point at 0, 0. Remember, we talked about the day we did the features in class. If you get the origin for the x-intercept, then the origin is also going to act as the y-intercept of your function. Vertical asymptotes still happen where the denominator equals 0. So we're going to set the denominator equal to 0, and I'm going to get a single vertical asymptote at +3. Proper versus improper. These are both linear, top and bottom. Since the degrees are the same, this is technically an improper fraction. How do I figure out the end behavior? You have to divide. Because the degrees are the same, top and bottom, that means that the end behavior is going to be the leading coefficients divided. So my leading coefficients here are -3 and 1, which gives me an end behavior value of -3. Because these come out plain numbers and are the same on both sides, we're going to have a horizontal asymptote at that same value, which is -3. Piecing together all of my feature points, or all of my features, I've got a point at 0, 0. I've got a vertical asymptote at 3. I have a horizontal asymptote at -3. So to figure out exactly where we are on the graph, using this table of values is going to be important for us. So notice I have a dot that's above the x-axis, or above the above the horizontal asymptote, which means that more than likely I'm going to have a huge chunk of my curve up here. If you're unsure and want to check, plot a point. Plot a number like 2. If I plot 2, I'm going to get a y value of 6. So that means I'm going to be way up here. So if I connect these two, that's going to go up forever. And then as I come down, I know that it's going to continue to dive down. I know it can't come down and go back up because, number one, there are no more x-intercepts, so I can't hit the x-axis again. And number two, I've got an end behavior of -3. So as I go out here and I get to my extremes, my curve has to get closer and closer and closer to my horizontal asymptote, or my end behavior value. On the other side, we don't know whether we're above here or we're below here, but it's going to happen one of those. So what I need to do is I need to find a value on the right side over here, a number like 4. And what we're going to see is does it give me a number that is above my horizontal asymptote? Or is it going to give me a number that's below the horizontal asymptote? So if I plug in 4, I get -12. That's a number that's way down here. If you're unsure, continue plotting numbers. If you want to, plot 5. You'll see you get -7.5. So again, we're still down below. If you want to continue on, plot 6. When you plot 6, you get -6. So notice that we're still down below the horizontal asymptote. So what that means is these are going to continue to rise, and then they're going to get closer and closer to that horizontal asymptote. This piece down here is going to continue to dive, and it's just going to keep going negative and negative and negative and negative. If I want to state my domain, all real numbers, and we're going to take out the one vertical asymptote value, which is +3. If you want to do interval notation, you'd need an interval for numbers smaller than 3 and an interval for numbers bigger than 3.